Hi, I'm Michael Cornwell with Pure Storage, and today we're going to be talking about how Flash has changed the storage array. In my hand is what traditional storage arrays use for performance and storage, which is a 2.5-inch small form factor disk drive. This is technology that has been around for 50 years, and there hasn't been significant performance increases in it for the last 20. One of the biggest problems you see is that you actually have high power consumption based on the motor spinning, and you have a mechanical system that ends up having to seek around, which causes a lot of latency issues for performance applications today. The problem with disk drives is that they're mainly optimized around moving the disk head as little as possible. The limitations here are just the scale of the amount of disk drives and then also the aggregation you need with a disk drive in order to drive virtualized workloads today. In a pure all-flash array, we use 100% solid-state disk. And the key advantage of solid-state disk is really the size of the medium. If you look at a flash system, the smallest medium of storage is a flash die, which in comparison to a disk drive has significant power and space advantages. Inside this single package is actually 4 equivalent disk drives, or 4 flash die, and each one of those is able to act autonomously. So if you look at a storage system like our Pure Storage all-flash array, we actually have over 2,800 flash die that we can access independently. In this type of system in virtualization, it allows for significant parallelization of workloads that enables breakthroughs in storage performance that you can't get with traditional disk drives. There's 2 big problems with Flash today. The first one is that it has an asymmetrical I/O size. What happens is you write in larger chunks than you read. And this is typically a big problem for operating systems and storage systems that have dealt with the same symmetrical access to disk drives for the last 50 years. And so what you need is a system that is capable of handling these changes in Flash, either geometries or different strategies in order to handle this right. In the Purity operating environment, what we have done is completely virtualized the I/O layer within our software stack in order to take advantage and have configurable access to these various types of memories, whether it's Flash, PCM, or other technologies that are going to come out. We have the capability to be highly configurable in order to access this technology in the most performant way possible. The second issue with Flash is something called burnout. What happens over a period of time, the more that you write the flash cells, they actually degrade and are unable to store electrons as well as they were when they were brand new. This is something that we like to call data fade, which is the period of time that your data is actually capable of being stored on flash. The Purity operating environment has the ability to move data dynamically throughout the system in order to ensure that data is never kept in one place long enough to let data fade occur. And this enables us to have orders of magnitude better reliability than traditional flash systems sold in the enterprise today. The thing that Pure Storage does that's very different than a lot of other enterprise array manufacturers is we actually use the cheapest cost per gigabyte flash that we can get our hands on. And the cheapest form of that is really an SSD. And when we say cheapest, we're not talking about what you'd find in a thumb drive. We're talking about a truly enterprise reliable SSD. The SSDs that we use have all the same enterprise characteristics that you find in most common enterprise SSDs today. But the real key here is the cost, is how flash manufacturers can bundle SSDs, how flash manufacturers can actually manage the physical medium in such a way that enables us to not have to worry about the reliability of these devices. But the trick here is getting the performance out of them. Everyone has heard stories about reliability or more performance reliability problems and inconsistencies with SSDs. The difference in the way that the Purity operating environment talks to SSDs is we talk to SSDs in the best way possible. So we've actually worked with the manufacturers of the SSDs and in some cases reverse engineered their firmware in order to figure out what's the best way to talk to the SSD so that we don't have massive write amplification, we don't have massive garbage collection, and we don't have performance variability in how we talk to these SSDs. And we really do that through this virtualized flash personality layer that we've developed in our operating stack.